again, this is my privilege. I had the privilege of learning from you, Vint, in a conversation and discussions last April in a meeting of the Trusted Digital Repositories ISO working group that was held at Goddard Space Flight Center. So in that respect, one of the pieces we saw in this is really with the interest across the government and across the scientific community and the public to basically learn about your insights and your perspectives on the challenges and the opportunities for digital preservation. I think we agree that this is still a significant challenge across many communities. So with that, it's my privilege to welcome Dr. Vinton Cerf, Vice President and Evangelist of Google Corporation, to share his perspectives on these challenges and these opportunities. So thank you.
Very much. So, I always get nervous when people clap before I said anything, and I think I should just sit down because it won't get any better than that. Actually, my actual title is Chief Internet Evangelist, so I'm not just a generic evangelist. I'm geek orthodox. So I do want to say something about NITRD because I was involved fairly early on in that activity. I served on the President's Information Technology Advisory Committee. And I can tell you that that was actually a very powerful, very effective cross-correlation across the agencies, even back then in the early 1990s. And it continues today to be a really powerful resource for coordinating people's R&D development. It's evidence that it's possible to have interagency cooperation. And in these contentious times, it's nice to see that the agencies can work together to produce better research. So what I want to do today is talk about how we preserve digital content. And I'm not going to be able to expose all of the issues and problems, but I hope I will trigger some discussion. And I think there's time in this session for at least a half an hour or more, depending on how long I run off at the mouth, to talk about some of the implications of these issues. So let's start out by making an observation that there is a substantial amount of digital content that's being produced every day, increasingly so as we depend more and more on digital devices for our everyday work. These things, the production of these digital objects produces very, very complex things. I mean, if you look at a spreadsheet, for example, yes, it's just a file, but it's filled with meaning if you have the right software in order to interpret it. So we create all of these very complex objects on a regular basis, and they enter into storage systems everywhere. We're also interested in describing what these things look like, what their structure is, what their semantics are. And so we have, the first problem is being able to describe these complex objects in a way that can be correctly interpreted in the future. The second thing is figuring out how to identify these objects, to give them labels that we can use later to find things again. And there are issues associated with the longevity of the use of those labels. Domain names, for example, are not stable. If you don't pay your annual fee, the domain name may fall into somebody else's hands or simply fall into disuse, and every URL that uses that domain name won't resolve, and a reference to it will fail. And it's very scary when you look at today's publications to see all those URLs in there that people intended to draw you to important content, and yet those things may no longer work even 5 years or 10 years or even tomorrow. So that's a big issue. Finding stable identifier spaces that we can rely on for decades or more is important. There is a question about taking content in to an archive and having a very regular process for making sure we've captured all the metadata associated with these digital objects that we want to preserve and make reference to. So there should be standard processes for that. There's also a question about where did it come from, what does it mean, how was it prepared, and this kind of information becomes increasingly important when the data turns out to be scientific data, measurement information. We need to know about the calibration of the instruments that produce the data. We need to know what the units were that the data represents. 5. Okay, 5 what? Is it centigrade or Fahrenheit or pounds per square inch or something else? So there is a substantial amount of information that has to be captured in addition to the specific content. Then there's this question about saving things in a legal context. So let's suppose, for the sake of argument, that you have created an object with a piece of software that's proprietary. And it turns out that, let's just take a text document produced with Microsoft Word just to be concrete. Well, the question is, 100 years from now, will that document encoded in the Microsoft Word format still be accessible to the people of the day? Well, will they be able to run the Microsoft Word program, which might not be current 100 years from now? And the answer may be no. So the question is, if you're thinking in those terms, under what conditions are you allowed to save a copy of the Microsoft Word program and then allow third parties to execute it, even if they didn't pay a license fee to do that? So you can make up a whole series of scenarios about this, where companies go bankrupt, companies are bought up by some other company, a product line is terminated for business reasons. There are all kinds of things that may interfere with the way in which we can preserve access to and use of data. And finally, there is a question about business models. If you're really seriously thinking hundreds of years, how many businesses do we know that have lasted hundreds of years, and yet the archive, which is supposed to hold on to this data for, until year, 3,000 or something, is going to have a business model that sustains that. So far, the only businesses that I'm familiar with that have longevity on the order of hundreds of years are the Catholic Church and breweries and wineries. And so I've never been able to figure out exactly how to connect the breweries and the wineries with the digital archiving, but it sounds like it would be a fun problem. And of course, as the chief internet evangelist at Google, I have this feeling that I have a religious commitment to preservation. But it's a serious question, what instrumentality allows information to be preserved and paid for that long period of time? I'm feeling funny about these slides. Did they really start out that way? Okay. We're going to flip through these slides because this is not how I remember my slides started, so I'm beginning to worry whether, okay, this is interesting. Well, we'll do it this way anyhow. Usually I start with that one, but okay, here we go. It's a very interesting problem to figure out how to ingest information into an archive and how to describe it. And when you get down deep into this stuff, you worry that the people who recorded the data in the first place and represented it in one way or another used language and descriptors that they were familiar with, they were comfortable with, knew how to interpret. But 100 years or 1,000 years from now, it's not clear whether the context and the meaning of all of those terms and representations will be clear. And so you have this question, what's the community that will be able to access the data from the archive and correctly interpret it if we have a group of people who understand the meaning of the descriptors and all the metadata and everything else? Over time, that community may shrink to zero, in which case you end up having to do a kind of recursive process where you define more and more precisely for future generations what the meaning of this stuff is. And so even if you think you've done the job, for, say, the next 10 years, you may have 10 years from now a new job to do, which is to refine the description so that someone who isn't familiar with the context can still figure out what the data means. So this process could turn out to be quite recursive. There's this system called Open Archival Information System, or OAIS, which NASA has been very much involved with. Its Consultative Committee on Space Data Systems has looked at and tried very hard to describe what an archive is, what it looks like, how it functions, what language it uses, what models it uses in order to capture data and preserve it over time. And so those standard definitions and descriptors and everything else are very important, because standardization will help us speak to the future generations about what this content is. And then, of course, you end up with special cases depending on where the data came from and what kind of data it is. If it's data from a Large Hadron Collider, that's one thing. If it's data from astronomical telescopes, it's something else. And so we need language that's specific to the kind of content that we're storing away. That's also true of things like programs, you know, the specific things that games, programs, analytical programs, and everything else. Some of these software packages are going to be very unique. I mean, if there's simulations, for example, of physical processes, and you may need special terminology and special descriptors in order to explain the structure of the content. We need to be systematic about this, and I think every one of you knows that the President's Committee of Advisors on Science and Technology and the Office of Science and Technology Policy have proposed that all research that's sponsored by the U.S. government have a preservation element to it. And so there needs to be a plan offered by the researchers who are funded by taxpayer dollars to preserve the information that they produce in the course of their research. I also think it's very important not to rely on any one place to store all this stuff away. And so architecturally, we want to have multiple things that we can identify as archives. They need to be able to interwork with each other so we can move data from one archive to another at need, partly to distribute risk and partly to cover the case where an archive is going to be, its business model has failed and we need to move the data someplace else. And then there's this question of what policies will provide incentives for creating and operating and sustaining archival processes. All of those things have to be dealt with. So this is not just a technical problem. This is actually a very complex business, legal, and technical problem that we have to deal with. So let me now go back to history for a moment and observe that we have been preserving a lot of information over long periods of time. For example, in the Babylonian and Assyrian periods, we had these cuneiform tablets. They weren't actually intended to last for 5,000 years. For the most part, they were records of transactions, storage in warehouses and big jars and so on, except that often fires baked the tablets into much more resilient material. I had dinner last Saturday at a place called 2941. The owner, Rick Adams, is a remarkable collector of written materials. And among his collection are the Archimedes palimpsest, which is about 1,000 years old, and a number of cuneiform tablets and other papyrus materials, Egyptian materials. And we spent a couple of hours just crawling around, having a great time looking at the historically preserved things. The bad thing about a lot of the objects that he has preserved or conserved or retained is that it's all by accident. It wasn't planned. A fire built, created a tablet which lasted a long time. Somebody stashed away a bag full of papyrus manuscripts in the desert where they didn't rot because it was dry, and it was discovered accidentally. We should not be doing digital preservation by accident. We should be doing this on purpose. But you can see that these various physical media have been pretty resilient. So papyrus is not particularly resilient unless you store it away in a dry atmosphere. But what about vellum? It's sheepskin or calfskin. Actually, originally it was calfskin, but the term generally refers to materials made out of the skin of animals. Sometimes you hear the word parchment. Those things last 1,000 years or more. And we were looking at manuscripts at 2941 that were 1,200 years old. And they were illuminated and magnificent and beautiful if you could read the Greek and the Latin and so on. That's the wetware that's required to correctly interpret the otherwise preserved objects. But these things, these are static objects that have been preserved in the media that you see on this chart. And then, of course, we have these wonderful inventions that we're all so proud of, and they store digital information for a few years as opposed to a few hundred or a few thousand. I still have 5¼ inch floppies in the closet somewhere, but nothing to read them with. 3½ inch floppies. I even have a 3½ inch floppy reader which plugs into a USB port of the Macintosh. It actually reads the files, but it doesn't know what to do with them after that because they're WordPerfect files, and I don't have WordPerfect running in anything. VHS, I hear that the last VHS production operation closed down now. I think I have one VHS, recorder or player at home, and hundreds of VHS tapes. So our embarrassing problem is that while we've invented these wonderful tools for storing digital content, we don't have any guarantee that they can be read in the future. So that's part of the challenge. It's a physical medium. We have to keep copying bits from one medium to another if we want to hang on to the bits over any reasonable period of time. And then there are other kinds of static materials like YouTube videos and photographs and so on. And I will argue that a video is, for all practical purposes, a static image. It's just a series of fixed images and audio recordings, but it's not dynamic in the sense that it doesn't change over time. It's a fixed object. So we've learned how to store a lot of that stuff fairly well. But I want to ask you to imagine that you are Doris Kearns Goodwin in the 22nd century. Some of you will have read the story of Lincoln's presidency. Her book called The Team of Rivals was actually astonishing. If you've read it, you'll recognize the remarkable ability she had to recreate in a credible way the dialogue of the time among the various principals. And I remember asking, how did she do that? It sounded as if she had been a fly on the wall in 1860, except we know she wasn't. Well, she went to, 100 libraries is just a fanciful number. I don't know how many she had to go to, but it was certainly a lot. She got the letters of the principals that they exchanged with each other. So she knew the topics of the day, and she knew the language that was used, and she knew the positions that many of the principals took. She was able to recreate that dialogue. Now, if you're in the 22nd century and you're curious about the beginnings of the 21st century, where would you get the emails and the tweets and the Quoras and the Facebook images and all the other stuff in the 22nd century? And it isn't at all clear that those things will be preserved. The companies that created them may not be in existence. Who knows, the cloud systems that have all that data may no longer exist, or somebody would have failed to pay their fees, and so their data has been flushed. It's possible that we're about to walk into a digital dark age where all this content is no longer accessible. And even if we've got the bits around, there are some other problems that we'll come to. So executable content is the next big problem, because this stuff isn't static. You have to run a program on a computer in order to make it do anything. And so if you have a complex file, like a video game or a spreadsheet, you need the software to be running in order to make that object useful. And we have a little problem with that. Here are all kinds of examples of these executable content that we would still need to run in the future. How do we do that? Well, we have to figure out what the bits mean, which usually means we have to run the software that created the bits in the first place. We need to know what those bits are, so we need the metadata. We have to have executable code or the source code. If we have the source code, we have to have a compiler to compile the source code into something we can run. And so the model I have in my head is that suppose you have a computer, like a laptop down there at the end of the table, running a piece of software. If I could take a digital X-ray of the machine, and this is a metaphor, okay, don't take this literally, but if I could take a digital X-ray of the machine, I would have the image of the instruction set of the machine, the hardware. I would have an image of the operating system. I'd have an image of the executable application program, and I'd have the bits of the complex files that that program interacts with. So if I could capture that digital X-ray in a reliable way and then store it away, I would have enough information in order to re-execute the program with the data that was associated with it. So that's sort of a flavor of where I think I want to go to solve part of the digital archiving problem. Now, we also have a problem that there's a lot of digital content that's being created more and more every day, so it has to get stored somewhere, so we have to have a capacity for a lot of data. This is true of your email and our tweets and all this, plus all the scientific data that we're starting to accumulate over time. I've already mentioned the various things that can happen to the companies that own the software or created the software, bankruptcies, for example, or sunsetting of applications. Then there's the intellectual property question. For some things that are copyright for 75 years after the death of the authors, you have no right to do things other than those granted to you by the copyright owner until that expires. So now if we're going to store things away that are subject to copyright that we intend to share with others because this is supposed to be archival information, there may be a time when we have to keep track of what the copyrights are, and then we have to figure out when they expire so that we can freely make use of things. Otherwise, we'll get into some kind of a legal pissing contest. That's a technical term, with people who have those rights. So we have to figure out what legal frameworks there are for exercising archival practices. And it seems to me, just like we have exceptions in copyright for what's called fair use, that it would be important to have an exception under copyright for archival purposes, for digital preservation purposes. There are no such laws right now. And so among the many other things we need to worry about is creating a legal framework which allows digital preservation to make progress. Now, at Carnegie Mellon, there's a professor there whose name is Mahadev Satyanarayanan. And I've practiced saying that many times, but we call him Satya for obvious reasons. Satya figured out, under NSF support, a way to emulate old operating systems and old hardware, or to emulate old hardware to run old operating systems in a reliable way. It's actually quite an interesting thing. That's probably not very visible, but this is not easy to emulate hardware correctly, because you have to get the precise meaning of every one of the instructions that the machine is capable of executing. You have to be able to run the old operating system. You have to worry about, dynamic link libraries. You have to worry about how the I/O is supposed to work. This is really hard. And then we have this other problem. When you emulate old hardware on new hardware, virtual machines, those virtual machines of today run so fast that it runs faster than it used to run on the old hardware, in which case sometimes the programs don't work right, especially if it's a video game. The computer is 100 times or 1,000 times faster than it used to be, and you'll never win, right? So you have the problem of trying to get this fidelity of the emulation exactly right. And so this is sort of part of the digital X-ray idea. What Satya did, he said also, when you build a virtual machine, it's actually a fairly big hunk of code. And sometimes it might not actually fit in the machine that you're trying to emulate or using to emulate. So he figured out that, that this was a very interesting possibility. He said he looked at what YouTube does when we're playing videos. We don't send you the whole video and then you play it back. We send it to you in a timely way. We hope we get enough of the frames and the audio there so it doesn't break up. But we feed this stuff to you. Now, video is easy in some sense because it's serial. It's frame by frame by frame. You don't have to guess. But when you're emulating a program, running a program, it hops around in the memory space. And so you can't always exactly predict what piece of memory it's going to need, what piece of software it's going to need next if you're essentially doing paging over the network. So he's figured out a way to do that fairly effectively, so you can run the virtual machine in the cloud, or at least have the bulk of the virtual machine in the cloud, and then run just a portion of it that you need in the local machine next to you. This is just to emphasize his demand paging idea for running a virtual machine in the cloud. He's been successful doing this for at least a dozen different operating systems. He was demonstrating, for example, running old DOS 3.1 programs on an emulated machine in the cloud with all the crappy graphics and everything else. I mean, it was very, the fidelity was very good. It was very impressive. And of course, this is what we need if we want people to experience what it was like to run programs back 25 or 30 years ago. So you probably don't want to dive too deep into this, but basically what he does is build a virtual machine emulator, and then on top of the emulator, he describes what the hardware is that it's supposed to emulate, plus the old operating system and the application and everything else. And that's the package of information is what actually runs. Now, this sort of works well for a self-contained program like a spreadsheet. It doesn't work quite as well if, for example, what you're trying to do is run a browser from 20 years ago, and the browser is taking web pages that have URLs in them. And when you click on the URL, of course, that exits the space of the machine that you're in. It's outside of the browser context, and you reach out to, well, maybe nothing, because that may not resolve anymore. And so this notion of emulating the hardware and running the old operating system only goes so far. If the system that you're trying to preserve is, in fact, the World Wide Web, now you have many, many more problems ahead of you in order to solve that problem, in order to make the URLs continue to resolve somehow, and we'll come to that in just a minute. This is just how he manages to package up the stuff that runs in the cloud. It's all one gigantic file. And he makes the exchanges between the cloud and the machine that you're interacting with that's presenting to you the old hardware and software. He makes this all look like ordinary web exchanges. So this is a purely web-driven infrastructure, but it's doing some pretty sophisticated stuff. I'll just skip over that. This is just another way of showing you what this looks like. So we're a long way from being done solving this problem. Part of it is the scaling problem. The virtual machines get bigger and more complex, the more complicated the hardware is that we're emulating. And the precision of the emulation is a big problem. He's run into a whole bunch of problems. Sometimes memory modes, like the x86 extended memory mode, didn't work very well in one of the most popular virtual machine systems called Keynote. He's also got problems with exotic hardware platforms. Think for a minute about what NSF sponsors in the way of research and the computing engines that are used in the supercomputers, for example. Imagine trying to emulate a supercomputer environment of 20 years ago in something. It's not even clear what that something should be. Now, he also runs into problems where the hardware had bugs and the software depended on the bugs. So he has to implement the bugs in the emulation of the hardware in order to make the software work correctly. I mean, having to know about weird stuff like that is part of the challenge. The other problem is that the people who make the hardware don't necessarily document it to a level of adequacy that would let you emulate it. And, you know, they'll say, well, it's proprietary information, you can't have that. And you're sitting there saying, but I need to know that in order to emulate the machine well enough to run the application software. For purposes of preservation, you know, you leave out you idiot part. But so there are really hard problems here hiding that are technical in nature or sometimes legal in nature, to say nothing of business models. So I think that if we're serious about and are concerned about our scientific enterprise, this needs to be an important topic. And we put this into our requirements. The OSCP has told NSF and others, you must, if you're supporting research, you must have your researchers give you a plan for preserving their data. But nobody who's busy doing physics research or biochemistry or something else is going to be expert in this sort of thing. And yet this sort of thing may be needed in order for their preservation to actually work. They save their files, they save their software, but the software won't run unless we have all these other things taken care of. Now, here's a very interesting notion. Today, we have this World Wide Web, and it has the property that it is the current collection of information that you can get to today. It's almost a self-defining thing. You know, the set of all sets. Does the set of all sets contain it? No, don't answer that. So we have what we have is what's there now. What we don't have is what was there before. And we don't have what is coming later. We just have what's there now. This is true, by the way, of the index that Google runs. That's an index which is being continually updated of what is there now. So it has nothing to do with what used to be there, for the most part. The problem is that nobody, except maybe Brewster Kahle at the Internet Archive, is trying to preserve what has been put into the web and might disappear. And so his Internet Archive is an attempt at doing that. He's been doing this since the mid-1990s. So we, Brewster and I and Tim Berners-Lee and a number of other people got together a few months ago to talk about the possibility of creating a World Wide Web, which has the property that when you post something to the web, it's automatically archived somehow, whatever that turns out to mean, so that you don't have to do what he has been doing. In fact, think about what Brewster does. He does what we do at Google. He crawls through the web. He captures web pages, and he stores them away in his petabytes of memory. If you've never seen it, he has a church, a building which he acquired that used to belong to Christian Science Church or something. And it looks like a church, you know, with the nice Greek columns and everything in the front. When you get down into the place where normally the pews and everything, where there might have been icons and things, he has stacks of memories, you know, going to the ceiling with flashing lights. So what he has to do, he grabs a web page and he stores it away, but then he has to go through every URL. And if he is going to pull the pages that that page points to, not only does he have to pull that page, but he has to change the URL that pointed to it to something that's local inside of his memory so that it resolves locally, because you can't guarantee that if he tries to resolve it on the World Wide Web, that it will still be there. On top of which, the World Wide Web may go away. I mean, it may not ever be there, you know, after the year 2020 or something. So, or, well, let's hope it lasts longer than that. Maybe 2120. Let's try 2120 or something. So his problem is to preserve the data as he captures it. So that's actually, it's sort of a manual thing. I mean, he doesn't have people typing URLs. But there's a process that he has to go through in addition to whatever the page creators went through to create those pages. So our notion, and this is purely notional at this stage of the game, I don't think we have a detailed idea of how to do this, is to make that whole thing more automatic so that when you post a page, when you say publish this, it also goes through some archival process. It's important to know at what point you should apply the archival action, because you don't want every single little change to the web page to create yet another archive. That's kind of like the multi-universe idea, where every time an atom, you know, sneezes, it splits into two and there's a new universe gets created. So we don't want that, but we want some well-defined time at which an archival action should take place. So we learned some lessons from the Internet's evolution, which I think apply to this creation of a distributed archive of what we now call the World Wide Web. One of them is that incentives for collaboration and cooperation turned out to be really important. And it was the effect of all that collaboration. It's what you do at NIDRD, writ large, among the research community and the user community, that has allowed the Internet to evolve and persist. Everything was open. The protocols have been open. The evolution process by which those protocols evolved, new ones created, is all open. Anybody could join the process. You can't actually join the Internet Engineering Task Force. There's no membership. All you can do is show up. And you know, like Woody Allen says, you know, 80% of life is showing up. And if your ideas have attraction to them, they'll take hold, and if they don't, they won't, and that's it. It's a pure meritocracy. Also, we said in the Internet that there would be an arbitrarily large number of networks, but we said we didn't care what the business model was. And so we dictated nothing on that score. And the result is we have parts of the Internet run by the government, parts of the Internet in private sectors. Some of them are for-profit, some are not for-profit, some are private, like, you know, the little things we run at home in our living room. All of those models are acceptable because the Internet itself didn't care. It doesn't rely on any particular business model. And that probably should be true for an archival system. Some of them may be for-profit, some may be not-for-profit, some may be government. There should be multiple archives, and they should have any means feasible of sustainable support. And then, of course, there needs to be a lot of modularity here, because there is so much detail that you don't want to have to know everything in order to do something. And so you want to layer the architecture of archiving in such a way that some people can specialize in this part, and other people can not worry about that and only worry about this part. It's a little bit like what happens with apps on mobiles. The people who write the apps on the mobile don't actually know how the mobile system works, and they don't have to. There's an API, an application programming interface. They know that if they can meet the requirements of that API for data transfer, that their applications can run. All the stuff that goes on underneath, the internet component, the Wi-Fi components, the LTE and 4G, 3G, and so on, all that infrastructure, that's hidden by that interface, and they don't care, and that's important that they shouldn't have to know. The same should be true for the archiving system. You shouldn't have to know very much in order to participate in and benefit from the archival system or contribute to it at different parts of its architecture. So I'm just thinking out loud now about the kinds of things that we will want to have in our toolkit for inventing a self-archiving web. One of them is to have the ability to compress the data just to reduce the amount of storage that's required. Things like tarball and formats like that have been used for a long time just to be efficient about storing information. We certainly want to recover. What did I mean by that? That's what happens when you think out loud. You begin to wonder what you meant. So what did I mean by that? Oh, I know. The question had to do with what's the what are the things that get stored in the archive? And you have to be able to draw a boundary around something in order to label it and identify it and find it again. So that means that you have to store things that you have identified as a digital object. So it can't be just blowing bits into the ether and hoping that somehow they'll be recoverable. You literally have to be disciplined about identifying something in particular that gets stored away. There is this interesting issue about when you should store intermediate versions of things. And this is a choice that we get to make. This is not dictated to us. But we have to be thoughtful about how many intermediate steps we're willing to remember and codify as a separate object, a new object. Sometimes you can escape this a little bit. In the case of Google Docs, for example, the way in which the document is constructed, we remember changes to the document. And so as the document evolves, the corpus of the document remembers its history. So we don't have to save version 1, version 2, version 3, version 4. We just keep the object, and as long as we're archiving it as an object and we update the archive of that current object, we have preserved its history automatically. And so this is a way of avoiding this question of having 10,000 copies or something. But it's important to be able to preserve the historical evolution of things. Think about what it's like if you're NARA, the National Archives. You want very much to be able to look back and understand the evolution of various and sundry documents. If we go all the way back to our origins of the country in the 1770s, one of the most interesting things is to see different versions of the Declaration of Independence. There was more than one version. Part of it, a consequence of not having all the states agreeing at the same time. They weren't all in the same room suddenly declaring everything. When the versions were printed and distributed, some states had not yet agreed, and New York might have been one of the holdouts. And so the language of the Declaration actually changes depending on which instance of the Declaration you get your hands on. The language changes to finally, ultimately, refer to all the states, not just some of them. And so in that particular case, we had physical instances of the versions. In the digital case, we might not have to have physically different instances. If some of you are familiar with the way programmers work, software, of course, is never done, and it always changes, especially if you find bugs that have to be fixed. There are aids to help you keep track of which version of the software am I working with now, how many different people are playing around with the code, is it only one person at a time that can edit it, and you check it out and check it back in again. So creating a framework in which this archival process can be disciplined is really important. And I've already alluded to the fact that the World Wide Web has its fragility and brittleness to it. So Brewster time indexes his snapshots. So he has a thing called the Wayback Machine, and you can actually search his archive with time as one of the elements. So you can look at what did the web look like in 1997. Of course, he doesn't have all of the web, but he has portions of the web from 1997. You get to look at that. And you can click on the web page and see what it looks like. Of course, this is kind of interesting because the underlying HTML has evolved over time from the original HTML format to XML to HTML5 and probably some other intermediaries. His software has to present to you, to the best of its ability, what that web page actually looks like under the interpretation that was intended. So we've already kind of touched on a lot of these on these topics. So I think we can actually finish that. So we have this problem that the web is bigger than itself in some sense. If you imagine that all we have of the web is what is currently stored. Storing the history of the web means you have to have more than the current web of space available. It's already hard enough to store the current web, let alone the past web. So we have a lot of work to do to improve the quantity of storage we have available, its efficiency, its compactness, power required, and everything else. The backward compatibility problem I've already alluded to, and of course all these questions about what are we actually legally permitted to do with the information that we've captured off the web. And some of the content of the web is supposed to be paywall blocked, for example. Well, are we allowed to archive that without having to pay to get behind the paywall? Under what terms and conditions would someone be permitted to do that? And what obligations would they incur as a result? For how long? Having dutifully archived the information, at what point are they allowed to make it available to people freely? Nobody has that worked out right now. So there are those issues that still have to be resolved. I like the idea of doing this stuff as automatically as possible because most people who create content don't really have the time, energy, wherewithal, or knowledge to figure out how to archive it. So we would be doing everybody a big favor, everyone who creates content, regardless of whether it's scientific content or any entertainment or anything else, we would do them a big favor if we create an automated way for them to preserve their content over time. Now, some people will tell you, well, most of the stuff on the web isn't worth saving. And I won't dispute that. It's sort of like, look at all the blogs there are. How many people read the blogs? The average is 1.4 people, the creator of the blog and the dog. So I'm not arguing that we should save everything. But I am arguing that if you did want to save something, there should be a way to do that. So we should have the technical capability and the legal and business frameworks in place, so if you thought it was worth archiving, you have the ability to do that. So I've been asking, people at Google, is there a role for one of the interesting properties of Google Docs? If you've ever used them, one of the interesting properties of the design is that multiple people can be not only looking at the document at the same time, regardless of where they are on the internet, but they can be editing the document at the same time. So there are multiple copies of the document, and those multiple copies are kept in sync in real time. So frankly, I'm astonished that the engineers were able to do that. It's really impressive. But the interesting thing about it is that it means multiple copies were replicated and kept in sync in real time, which is what you would want if you had a distributed archive. You'd want things to stay in sync as quickly as possible. So there may be the methods that were used to achieve that in the Google Doc case might also be applicable to a distributed archive. It's also very important that we find a labeling and identification space that's stable over long periods of time, which means if we identify an object that we want to store away and we give it a label, the label should not be assigned to anything other than that object, and the label should be resolvable over long periods of time. There are all kinds of implications of that. It's sort of like domain name system having to be around forever and ever, amen, to resolve a URL. We need this other, whatever it is, label and identification space to be preserved over long periods of time so resolution will work. One of the things that's interesting about this is that inside of the Google Cloud, the files that we keep are not actually kept in a unitary form. They are broken up into pieces. The pieces are scattered across multiple data centers, so even if we lose a whole data center, the document is still there in almost a holographic form. And the identification part allows you to reassemble the pieces when that document is referenced. So we have bits and pieces of the elements of a digital archive. At Google, I'm not suggesting that Google is the exclusive agent through which this technology has been developed or could be developed. It's just that it has something to contribute, as I hope others do. Some of you are familiar with the publication, publish and subscribe notion. It's a very popular idea. And I think that's part of this archival thing. You should be able to assert that I'm publishing this, and by the way, by implication, I want to archive it. And if somebody else wants access to that content, they should be able to subscribe to it. So there's some pub-sub component to all of this. What about all the metadata? The tools that allow us to create content need to also understand the meaning of metadata and the need for it and the ability to capture it and store it away with the document or with the object. And if we don't do that, of course, then we'll have a big problem because we'll have a bag of bits that has a label and we can find it again, but otherwise it's not clear exactly what it is. So the metadata is necessary. This rendering and interpretation thing is important too, because once you find a digital object that's been archived and you want to do something with it, and you're out here at the edge of this system, when that object shows up, you need to have the software that's needed to correctly render it if it's a static thing or, it's video or something else, or it may actually require interpretation. So the act of retrieval has to recover the context in which the object can be interpreted. And I'm not even going to take time, the permission to use question, who can use what and under what circumstances. We need vocabulary for that, and we need mechanisms for registering what rights you're willing to give and under what conditions and for what period of time for all these various digital objects. And again, as much of this as possible needs to be automatic because a lot of people won't take the time to do that themselves. So here's an interesting problem. If I am looking, this is surfing the self-archiving web. If I'm looking for an object and I find a reference to it, okay, so I've got the handle, so to speak. The question is, where do I go? Where does it resolve to? And it should be the case that there's more than one, useful resolution. I don't want it to only be one place that holds this object. So no matter which resolution I get, I should still end up with the object that I'm looking for. This is the snapshot question of when do we take a snapshot of something and say it's an archivable moment. And I think we really, really need to work hard on that. The publishing of magazines, the publishing of a newspaper has the notion of edition in it. And that helps us draw a box around something and say this is an object whose content we want to archive away as this edition. When we have this rather fluid web environment, it's not clear what an edition is, so we may have to invent new concepts in order to control the rate at which snapshotting takes place. So automatic archival upon asserting that you want to publish. If this is a distributed World Wide Web archival system, how do you sign up for it? And who pays for it? What about the rendering engines and also the executable software? Do you register that somewhere to say, here is my product. This is useful for editing photographs, and I want other people to have access to it, but there are terms and conditions associated with it. Either you are able to get access to a copy of the software and you can download it and somehow run it in an emulated environment, or maybe you have to run it in the cloud. I don't know whether you've noticed this, but the people who used to make software that would sell you a copy of the software don't want to do that anymore. They would like to sell you the right to use, the license to use, but the software is running in the cloud somewhere. You don't actually get it. You never do. All you do is keep paying to use it. And they like that business model better because having to keep coming up with a new version of software that you're willing to pay for is less attractive than you can't use this at all unless you pay me, for the next month's rent. So there's that. Now, what about the other problem? Suppose none of you would do this, I'm sure, but suppose that you thought, boy, wouldn't it be fun to archive away really malicious viruses, worms, Trojan horses, and other stuff, and induce people to click on a link. You could even, some people, if you said, do not click on this link, this is highly malevolent virus malware. 4 out of 10 people would click on the link. It's sort of like wet paint. I wonder if it's still wet. Right, okay. So I don't know what to do about this. If you have this distributed archival system and somebody wants to archive away a virus, which you might want to do. I mean, you might want to capture what we've discovered about the dark side of the web. But how do you filter this? How do you protect people from accidentally ingesting, malware? And then there's this question of how good is the archival process? When I retrieve the object, what do I get? One possibility is you just get to see what the object produced. Sort of a very two-dimensional, here's what it looks like. Or you get something where everything works and you can interact with it, play a game, run any spreadsheet, download new things. So there's a question about saying something about what the fidelity of the emulation and recovery is, and we'll have to have new vocabulary for that. So suppose that the archive is really, really good about saying this page has been stored away, it's part of the archive, and it can't be changed without visible damage. Digital signatures and digitally signed hashes might allow you to say this page, if altered, will be visibly altered because we can test that. Well, if you actually put in some kind of a mechanism like this in the archival system, you might imagine that would be very useful in a court of law because you could say, this object was stored at such and such a time. It was a contract between these two parties. They both agreed to it. I have mechanisms to prevent either of them or some third party from altering the contract without it becoming clear that that's what happened. And that now becomes an interesting piece of legal evidence. I don't know that we should deliberately try to create that feature in the archive, but the side effect of some of the things that you might want the archive to do might also produce that effect as well. That might be quite useful. There's also this question about the act of archiving something being a requirement for official record keeping. And those of us who either work in or have worked in the government know that there are requirements for record keeping, and the archive, if properly constructed, could satisfy that particular requirement. And finally, what about the problem of access control in a timed way? So sometimes people will put information away, like in the presidential archives, and say you can't have access to this for 50 years, or after a certain event has occurred. The archive might also try to observe that set of requirements as well. Some of you will know that there are concepts that are starting to show up in the cloud environment. One of them is called containers, and it's a way essentially of trying to take a body of software and make it work in any cloud-based system. And so if you could, the clouds don't all work exactly the same way, but a container is intended to allow you to move things from one cloud to another. That would be a very good property in the archival sense, so that you can have multiple archives, and the containerized software that's needed could run on all of them. And so that might turn out to be a very useful mechanism as well. So I think this is the last slide. I've already mentioned the Internet Archive that Bruce Rattale has been running. The Library of Alexandria, the one in Alexandria, Egypt, is one of the backup sites for the Internet Archive. And I think there's also one in, I want to say, Japan. I think, or Tokyo, or Singapore, one of the two. The Computer History Museum out on the West Coast in Mountain View also has been archiving things. In addition to just digital content, they've been archiving software as well, and so has Brewster. Although the archiving of the software has mostly been preserving the bits of the software, but not necessarily an environment in which they could execute. Google, of course, has been doing book scans, and the Cultural Institute has been capturing digital images from museums and cultural areas for a long time. And finally, there's Bob Kahn's work on what's called the digital object architecture. He's created an identifier space he calls digital object identifiers, and those of you who read scientific publications will often see DOI : and then some string. That's actually a digital object identifier, which if you plug into a browser will resolve into a URL, which eventually gets to the target if the target's still around. The way it works right now is the inverse of what is needed, because the URLs themselves are not necessarily stable, but the DOIs could be if we could map directly to the target. So I think that's an hour's worth of on, and I